Hello, fellow geometers. It's Mr. Couples. I'm going to go over with you real quickly, or try to as quickly as possible, the review from section 7.3 and 7.4. And let me just say this before we get started. My purpose in doing the quiz tomorrow is to really figure out if you know what you're doing. I'm not going to give you simple problems where you don't have to do any thinking. I really want to challenge you. Do you know your way around these special right triangles that we've been talking about? And if you don't, I'm going to figure it out pretty quickly. And so what you're going to be given tomorrow, looking at number 1 here, with the 30, 60, 90 triangle, I'll probably give you something that will look sort of like this on the board. Okay, this will be the 30-degree angle, the 60-degree angle, and I'll label the sides x, 2x, and x radical 3. Okay. So from there, I will expect you, the reason I'm going to give that is because that's the same thing that you're going to be given on the OGT for you sophomores that are taking that this year. And so I don't want to give you more information than what you're going to be given on the OGT because I want the expectations to be the same. I want you to get this right. So if you have to memorize it, you have to memorize the formulas if that's what you normally use. And so if I do that, hypotenuse is going to be twice the shorter leg is the formula because we can see it's double right there, 2 times the shorter leg. This is obviously the shorter, opposite the 30, obviously the hypotenuse, and then the longer leg. Okay? And the longer leg is the shorter leg times radical 3. So again, if you have to memorize those formulas, go ahead and do that. So if I label the 3 sides over here, hypotenuse, longer, and shorter. All right. I can tell you right now the hypotenuse is going to be 14 and the shorter is going to, or the longer is going to be 7 radical 3. Now if you've got that, you can fast forward to the next part. If you didn't get it, you can pay attention to this next part. So how do we get 14? Well, we're going to plug 7, which is the shorter side here, in for the shorter side length. And so the hypotenuse, which is y, has to equal 14. There's nothing to do there to solve for y. It just is what it is. So that is that. And then down here, the shorter again is 7. So I'm going to plug that in for the shorter side length. And the longer leg, which is x here, again, there's nothing to solve for. Very simple. So is it probable that I'll give you a problem like this tomorrow that's that straightforward? Maybe a 1% chance. Okay, not a very high probability. For the 45, 45, 90 triangle, what I will give you is a picture up on the board like this. Okay, and I'll probably label the angles as well, 45, 45, 90, and I'll write x, x, and x radical 2. So what's the formula you need to memorize for this one? It's just that the hypotenuse, which is this side right here, these are both legs. Okay, the hypotenuse is the leg times radical 2. Okay, so I like this one because this isn't your typical kind of radical. You have to know your way around the figure. Now, no one should get the first part, which is x is going to be 5 radical 3. I hope everybody gets that part right. But for the y value, I will tell you it's going to be 5 radical 6. And if you got that, again, fast forward. If you didn't, I'm going to talk you through it. So my leg, each of the legs, as you can see over here, the legs are going to be 5 radical 3. So I'm going to plug that in for my leg value. And I'm going to plug in the radical 2. And I'm going to solve for the hypotenuse, which, as we see here, is the y value. If I simplify this, I get 5 times radical 6. And I can't simplify 6. The factors of 6 are 2 and 3. There's no duplicates or perfect squares. And so that is all I have to do for that one. Very simple, straightforward problem. So for number 3, again, if you struggle with any of these problems here, please go back and review them. And then if you still have questions, obviously tomorrow I can field maybe a couple before we get started. But I want to get right into it tomorrow. With this one, the 30, 60, 90 triangle, I'm going to go ahead and label my long leg, my short leg, and my hypotenuse. Okay? And what I know is that the hypotenuse is 2 times the shorter leg. So if I double this shorter leg length, okay, you're going to get your hypotenuse length, which is x. 2 times 7, I'm only multiplying like terms there. and I get my value of x, which is 14 radical 2. For my longer leg length down here, the longer is the shorter times radical 3. The shorter we know is 7 radical 2. I bring down the radical 3. Like problem number 2, we're just going to go ahead and multiply those two together. And so the longer leg, which is y, is going to be 7 radical 6. Again, I cannot factor radical 6, so that's all the further I can go with that. Now for these figures like number 4, I would encourage you almost to draw the triangle separate. And so as we look at number 4, I'm going to draw this 30, 60, 90 triangle separate of the figure. Okay, we have D here, we have A, and we have a length of 9, and this is 60, and this is 30. Okay, so this is my shorter side, this is my hypotenuse, and this is my longer side. Now the hypotenuse up here is twice the shorter side. Twice the shorter side. So if we plug in the shorter side length, my hypotenuse, which is D, has to be a length of 18. Okay? So again, we're doubling the shorter side length. The longer leg is the shorter times radical 3. Again, the shorter is 9, so I plug that in for the shorter side length. The longer is A. Nothing else to do there. I take that 9 radical 3. Now that 9 radical 3, that A is in both triangles. Okay, remember the reflexive property from chapter 3 and 4, I believe. It's been a while. Okay, and so we have this 45, 45, 90 triangle. Now, if A is 9 radical 3, the angles being congruent tell me that B has to also be 9 radical 3. Those lengths are the same. Now the hypotenuse length, here's the hypotenuse, and these are both legs. Okay, the hypotenuse length is the leg times radical 2. And so from there, if I plug in the leg lengths, which are 9 radical 3, times the radical 2, this 2 is just coming down here, the hypotenuse, which is C, would have to be 9 radical 6. Okay, that radical 6 showing up an awful lot today. I don't think that has any bearing on what we're going to do tomorrow, but just letting you know, we can't simplify that. Just a quick hint on trying to remember which one of these two triangles has the radical 2 and radical 3. I like to remember that in this triangle, there's only two different types of angles, a 45 and a 90. So if that helps you out at all, okay, this triangle has 3 different angles, the 30, the 60, and the 90. So as a result, it's going to be the square root of 3. So if that helps you, use that as a tip. So, all right, number 5. Again, you notice I'm moving kind of quickly here through these. I don't want to take your time, but if you don't understand something, again, go back and look it over. What I'm looking at number 5 is this. I've got 2 parallel lines, so that tells me I have a trapezoid. The area of a trapezoid, remember, 1/2 height, base 1 plus base 2, okay? And we want to go ahead and figure out, we've got the 2 bases. I'll just label the first one base 1 and the other base 2, okay? But we need the height. Now the height is actually this length right here. But I'm going to move that length over here, and voila, we have a 45, 45, 90 triangle. Now the question is how do we find the height not knowing any of the sides of the triangle? Well, hopefully most of you figured out that this length right here, you can go ahead and take the difference of these 2 side lengths. So 21 minus 12 is going to be 9, and this length right here is going to be 9 as well. And so when I plug this in, 1/2 the height, which is 9. The 2 bases are 12 and 21. And so I'm just going to do this longhand. Half of 9, that gives me 4.5. And then bringing these two together like terms, I get 33. Okay, 33 times 4, 120, 132 and a half, 16 and a half. So we end up with 148 and a half square units. Okay? All right, make sure you label all your answers tomorrow too. And I'll try to remind you of that as well. Number 6 is very similar to number 5. I want to clear that off so we can look just specifically Number 6, same formula as before. Area equals 1/2 height, base 1 plus base 2. And as I look at my figure here, I don't have the height and I don't have my other base. I do have one base, okay? So I'll put 3 right there, and we have to figure out what the other what the other base is going to be and what the height's going to be. So what I'm going to do, anytime you see an angle measure like this, or an angle measure like this, there's a reason why they're putting it there for you, okay? And so be smart, make the right triangle, and see if you can figure out things from there. Now obviously this length here is going to drop down to this length here, so I'm going to make that a length of 3. And we have the hypotenuse here, so I'm going to start with this triangle here because I know some things about this triangle. So here's the hypotenuse. We have a leg and we have a leg. Now over here in the 30, 60, 90 triangle, this is the longer leg, this is the shorter leg. I need to figure out both those parts. So in the 45, 45, 90 triangle, we know that the hypotenuse is the leg times radical 2. And so if I plug in 4 radical 2 and I solve for the leg length there, well, I'm going to go ahead and divide by radical 2, canceling those out, giving me a height of this trapezoid of 4. So both of these lengths are both equal to a length of 4. So I can go ahead and put that into my formula there. Now the shorter side length, actually I should show that this is also 4 because that's part of my base down here. The shorter side length is the longer leg times radical 3. Okay, shorter times radical 3. So my longer leg is 4. My shorter leg is unknown. We have to figure that out. Now, like in the last equation up here, we are going to divide by the radical. This time it's radical 3. And then we are going to rationalize that radical in the denominator by multiplying it by radical 3 over radical 3. That gives me 4 radical 3 over 3. Okay? Now, this is where it gets a little interesting. Okay? I already know that this base is made up of a length of segment 7 units long and a segment that's 4 radical 3 over 3 units long. So I'm just going to write this 7 plus 4 radical 3 over 3. The reason I'm doing that is because this and these are not like terms. We've talked about that. I want to continue to remind you of that. The radical is treated like a variable, therefore it cannot be combined with other numbers that don't have the same radical. And so just walking you through this, half of 4 is 2. 3 and 7 make 10. Okay? And I know we've done this next part previously, but I want to make sure that you get this. I'm going to put this over 1, and I'm going to put this over 1. And the reason is because I'm going to multiply all the numerators together and all the denominators together. So when I take 2 times 10, that's easy, that's 20. Okay? 2 times 4 radical 3 gives me 8 radical 3. And 1 times 3 is just 3. And so as a result, I'm going to leave it completely separate, again, because they're not like terms, and that's my answer in simplest radical form. Okay? I can guarantee you're going to have something similar to that on your test tomorrow. So I hope that all made sense. If we look at the next problem, number 7, we want to find the area of this trapezoid again in simplest radical form. Now these x's are here because they tell me that whatever, forming the right triangle here, because again we have that 60 degrees there, whatever I get for this length, if I double it, I'm going to have the entire length of this base right here. All right, so I'm going to put 30 here. This is my hypotenuse. This is my shorter side, and this is my longer side. So the hypotenuse is twice the shorter. The shorter side is x, and the hypotenuse is 9 radical 6. Well, to get x by itself, we're going to divide by 2. And if you want to leave it as 9 radical 6 over 2, you can. I'm going to go ahead and make it 4.5 radical 6. Now, I know I've told a lot of you to not have decimals as part of your answers there, but it's key that it's not underneath a radical. We never see a radical really with a decimal underneath it. And so That's why I'm okay with making it 4.5 radical 6. Now, if this is 4.5 radical 6, and this is 4.5 radical 6, adding those together, think 4.5x plus 4.5x, that gives us 9x, so this is going to be 9 radical 6. Okay? So that's my second base. I'll make that base 2. This one right here is 4.5 radical 6. I'll make that base 1. And now I just need to find my height. So my height, which is the longer leg here, the longer leg is the shorter times radical 3. The shorter we said was 4.5 radical 6. Multiplying that one by radical 3 to get my longer leg, or my height of my trapezoid. Here's what we have. 4.5 radical 6 equals radical 18, but I know 18 is going to break down into some numbers. So what I'm going to do, the factors of 6 are 2 and 3. 3 just comes down, breaks apart right there. And so we see we've got a perfect square of 3 that's going to come out. Well, 3 times 4.5, that's going to be 13.5 radical 2. And that's the length of the height for that trapezoid there. So again, 13.5 radical 2. Oof, that's sloppy. Sorry about that, but I think you see what's going on. So the area of this trapezoid, 1/2 the height, 13.5 radical 2, times the sum of the bases is going to be 4.5 radical 6 plus 9 radical 6. All right, well, doing this shorthand, okay, half of 3.5 or 13.5 is going to be 6.75 radical 2. And I'm going to multiply that. I'm going to add these two together. They are like terms. We've got the same square root of 6 values there. So this is going to be 13.5 radical 6. Okay? Now, you'll notice these aren't like terms, but we wouldn't be able to add them or subtract them from each other, but we can multiply or divide them. In this case, we're multiplying, so I can continue to do this. So if I do that, 6.75 times 13.5, I had to look this one up on the calculator, is going to be 91.125. And then we end up with 2 times 6, which is 12. Well, if I leave those factors separate, I'm going to bring the 2 straight over. The 6 right here breaks down into a 2 and a 3. And so I've got a perfect square that's going to come out as a 2. And I multiply 91.125 by 2. And you have 182.25 radical 3 square units. Okay? And so that's how you would find the area of that figure. Again, it's not hard. It's not something that's like just mind-blowing. There's a lot of work up there, but start small. I started with just the 30, 60, 90 triangle. I broke it apart, made it into things that I know, and then expanded from there. So don't look at the whole big picture before you just break it down into parts. Make life problems easy. Okay? Don't try to do them all at once and you just get frustrated. Okay? Break them down into parts. All right, let's go ahead and take a look at this next one. Solve for the area of the rhombus. Leave your answer in simplest radical form. Now, the area of a rhombus, if you don't remember from a couple of chapters ago, is 1/2 diagonal 1, diagonal 2. The 2 things I know about the diagonals of a rhombus is that they are perpendicular and they bisect each other. Okay? And so it's good that they're perpendicular because I know this triangle then becomes a 30, 60, 90 triangle. And so I'm going to mark down that length as 8. That means this one diagonal is 16. So I'm going to put down 1/2 of 16. And then I have to figure out what the other diagonal is going to be. Now, this is the shorter side, opposite the 30-degree angle. This is the longer side, opposite the 60-degree angle. And then you can go ahead and mark your hypotenuse, but that's not necessary because all we need is the diagonals for this problem. So, the longer leg is the shorter leg times radical 3. We said the shorter was 8, so I plug that in. The longer leg is going to be 8 radical 3. Now, we need the entire diagonal length, this whole thing right here. And so the diagonal, I'll say D2, is going to be 8 radical 3 plus 8 radical 3, which gives us 16 radical 3. Think 8x plus 8x is 16x, same thing, 16 radical 3. Okay, so when I plug that in, I'll take half of 16, which is 8. And 8 times 16 is going to be 128 radical 3 square units. Okay, so yeah, breaking that down in parts, saw the 3690 triangle, working out from there. All right, now for the last two, we're finally here. Okay, we have both a 30, 60, 90 triangle and a 45, 45, 90 triangle. Now, in either situation, you want to start with the triangle that you know the most about. Again, I don't think I mentioned this earlier. Area of a kite is the same formula as the area of the the rhombus. Excuse me. Okay. So from there, I'm going to redraw that triangle separate so we can see it a little bit better. Okay. 60, 30, and this is 9 radical 3. That's your hypotenuse. Okay. This is your shorter side opposite the 30. This is your longer side opposite the 60. We know that the hypotenuse times 2, or the smaller side times 2 is the hypotenuse. So I don't know what my shorter side is, but I do know my hypotenuse is 9 radical 3. So we can divide by 2 here to get the hypotenuse, or the shorter side length, which is going to be 4.5 radical 3. Okay, that's your shorter side length. So if you want to, in the picture there, I'm going to go ahead and put that down, 4.5 radical 3. Okay? The longer leg in our picture there is going to be the shorter leg times radical 3. Well, the shorter leg is this right here. So when I plug that in, 4.5 radical 3 times radical 3, this radical 3 is just coming from that radical 3. Anytime we have two of the same, if you want to rewrite this portion separate, as in radical 3 times radical 3, 3 is just going to come out and it's going to multiply by what's in front. So the longer leg is 13.5. Okay. Now, that longer leg is also a leg of the 45, 45, 90 triangle. So I know that this length is going to be the same. And in a kite, I think you can probably see this without me saying it, but this triangle and this triangle are congruent to each other. They're both 45, 45, 90 triangles. So I know that this length is also going to be 13.5. So as a result, the one diagonal, 13.5 plus 13.5 is 27. The other diagonal, I can't add these together because they're not like terms. So I'm going to leave it 13.5 plus 4.5 radical 3. Now as I simplify that, half of 27 is 13.5. And then I'm just going to distribute the 13.5 to both terms there. And that will give me 182.25 plus 60.75 radical 3. And all this is square units because it's an area. Okay? So, again, breaking it down, make it simple, and then work your way out. All right, the last problem. In the last problem, again, we have a rhombus here. We're trying to find the area of it. 1/2 D1, D2. The first diagonal, since they bisect each other, is going to be 18. 9 plus 9. The second diagonal, we have to figure out. Now, we don't know if this is a 30, 60, 90 triangle. We don't know if it's a 45, 45, 90 triangle. So what do we do when we only know 2 of the 3 sides and we don't know what type of specific triangle it is? We do the Pythagorean theorem. I'm going to label this x, and then I'm going to do 9 squared plus x squared is equal to 10 squared. 81 plus x squared is equal to 100. I'm going to subtract 81. And then I'm going to square root 19. Now 19 is a prime number. There's no other factor that goes into 19 evenly, and so I can't break it apart. There's no perfect square underneath that radical. Now, I do want you to know that there's an x here and there's an x here. These diagonals bisect each other. So as a result, we have to add those two together. Well, to get the second diagonal, if I'm taking radical 19 plus radical 19, what's that going to be? Is it going to be 2 radical 19 or is it going to be radical 38? Well, I hope you said 2 radical 19 because x plus x is 2x. Same thing with this one, 2 radical 19. So when I plug that in, I'm going to take half of 18, which is 9. And 9 times 2 is 18. Radical 19 square units. Okay? I realize that was kind of fast. I hope that you understood everything I went over. If you didn't, please come see me tomorrow morning before school. I'd love to help you out. I expect you to know this for tomorrow. So, good night.